All right, we are going to go over the unit review. It was this page right here. You do have a test on Monday. Monday's test is 25 questions long. I went through it, double checked, definitely use the review sheet we made yesterday to help you review for that test on Monday. These set of questions, they were helpful, but it was really concentrated on more deposition on here, which is on the test, just not quite as much as on this worksheet. So starting off, what conclusion could you make about these evidence or these soils that were greatly different than the bedrock below them?
Great.
Yeah, they were transported there. So the reason they're different is because they're transported.
We've had that question before.
Yep, there's only so many ways it can ask a question about the same topic. It's going to end up being very similar. Austin, you with us? You're not on your phone or anything, are you? No, make sure that gets put away. Okay, this one here, not going to, yeah, it's not going to be on the test, but I bet you could figure it out. So it says the diagram below shows soil profiles shown in an area of granite bedrock. 4 different soil horizons are shown. So they show A horizon, a B, a C, and a D. And they want to know which one has the greatest amount of formed by biological activity. What is biological activity? Living things. Which layer is going to have the most living things? A.
Oh, I thought it was talking about bedrock.
Okay.
D bedrock?
D is bedrock, but nowhere on there talks about bedrock. So
Yeah, well, I thought that.
the good news is this will not be on the test. I do soils later in the year, so Mr. Mika does them now with weathering and erosion, which fits as well. I do them later in the year when we talk about the water cycle. So it goes either place. So don't worry about this, is not on the test. This next one is absolutely on the test though. The longest settling time. And actually, before we do answer this, when it says longest settling time, does that mean it settles fast or slow? Okay, so that is something they're going to try to mess with you with the way they word it. Longest settling time means slow. So which one's going to be the slowest?
Low density.
Low density and flat. Now, again, we didn't specifically talk about wind and waves, but I bet you can figure it out. If it's not windy, what do you know about waves?
They're flat.
There's very little waves if it's not windy. What if it's really windy?
Big waves.
Big waves. Which graph says no wind, little waves, big wind, big waves? That's answer 3. That's a direct relationship. And then this one again is very similar. Which one's going to be the last to settle as the river's velocity decreases? Again, what does it mean last to settle? Is that fast or slow?
Slow.
Okay, again, I would read those carefully to decide, are they talking about slow or fast? So we already established small and low density and flat are going to be slow. Which one is the correct answer then?
A.
Yep, clay is the smallest. Again, if you forgot which one is the smallest, always check the graph here. It'll take you 5 seconds to see that clay is the smallest. And then we're going to keep going to the back. Again, very similar question. Which one will settle to the bottom first? Are they looking for the fast or the slow one there?
Fast.
Again, settles first is fast. They did tell you in the reading that they were all spheres and they were all the same size. The only thing that's different is their densities. So which one will settle fast?
Hematite.
Yep, hematite, because it's got the biggest density. Again, same idea here. Which one? Why does lead settle faster?
Because it has a higher density.
Yep. And again, in the reading, it did tell you same volume and they were both spheres. Again, practically the same question here, though this time they told you they were all copper. And I feel like, oh, they were right here, equal mass. So they were pieces of copper that weighed the same amount. Well, then why did they settle at different speeds? What must have been different?
Shape.
Okay, that would be their shape. They have the same density because they're all copper. They have the same composition because they're all copper, and color has nothing to do with how fast they settle. This one, it was really important to read this one carefully. When particles of uniform shape and density are dropped into a calm lake, silt will settle faster than. Silt will settle faster than clay because clay is smaller. It was important to read that. If you just said which one settles faster, you probably would have picked cobbles because it's the biggest. But that wasn't what they asked. And 10, where is deposition likely to happen?
2.
At the mouth of a
Yeah.
stream.
That's what I said. Oh.
Yep.
Yeah, that's what I said.
That's good because that's correct. And then finally, which one? So A has the shortest settling time. Again, is that fastest or slowest? Okay, that's the fast. Which one of these will settle faster? That is the round one. Just be careful if they give you a rate. If this was changed to rate and it was in meters per second or even millimeters per second, and those were the numbers given, which one would be faster then if they were meters per second? Why in meter?
Because it's the fast.
Okay, so if that's kind of like miles per hour, if you're going 25 miles per hour, you're going faster than if you're going 5 miles per hour. So just be careful whether they say rate or settling time. There is a difference. All right, so in preparation of the test on Monday, we're gonna play some Kahoot. So grab, you're gonna need your reference table. There are a couple which I do believe, actually, let me see if I can go real quick and change. There is absolutely one that needs the time change. Don't look at the answers.
Wow, so you can look at my computer screen and
All right, here we go. If you want to move, you're welcome to move. Oh wait, my favorite. I'm reading this about free trial. Why is this not going away? Wow, look at you guys go. 1, 2, 3, 4, 5, 8. Sorry, I am not in charge. Okay, we need one more person, right? Stan, you logged in? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We good? Yeah, let's start. This one I want you to do it through process of elimination. Which one is not related to chemical weathering? One of them is not chemical weathering for sure. Yeah, so dissolution, I understand why you picked that one because we did not talk about it. However, frost wedging is absolutely not chemical weathering, that's physical weathering.
Wait, this solution would be like dissolving.
Yep. It's actually coming out of solution, like not solution. Rocks that are carried by a stream are. You are welcome to use your notes or your reference table. Nice job, rounded. Wow, big changes there. Oh, I gotta hit the button. Don't walk away.
Don't you wish that was touchscreen?
I do regret not getting the touch screen. Which climate condition is ideal for physical weathering?
Yeah.
Come on, you guys. Well, obviously we always need water for any type of weathering. So not the cold and dry or hot and dry. By the way, do you know some other words for, wet,
Yes.
moist, damp? Keep
Wet.
going.
Precipitation.
Okay. How about humid?
Slippery.
Juicy.
Humid is actually the one. Humid is the one I want to talk about. The regions will use the phrase humid climate. And do you guys know the opposite of a humid climate?
Arid.
Arid. So yes, dry. Yeah, you're not wrong. The regions will use those fancy words, humid and arid. So if you see humid, think wet. Arid, think dry. Which mineral would be most resistant to weathering? You might need your mineral chart on your reference table.
Going off my mind.
You probably can do this one off the top of your head if you can picture where they are.
Oh, yeah.
You only have 4 seconds left though, sorry guys.
Oh.
Okay, the most resistant is the strongest one, which is quartz. It's lowest on the reference table, the mineral chart. That's how they tie chapter 3 and chapter 5 together.
That's what this guy was talking smack and guessing on the podium.
Oh, okay.
He just got it wrong.
Which process are rocks moved to a different location? Deposition is the dropping off at a different location. Erosion is the moving. As the stream slows, which particles are deposited first? Largest and most dense. So by the way, I would like to talk about this picture. So you have a river flowing into a lake. What could you expect to find in zone A? The biggest rocks.
Boulders and cobbles.
Yep, so you'll find bigger rocks in zone A. And what is gonna change as you go out towards
They're
zone
gonna
B?
get smaller and smaller and finer and.
Okay.
rounder.
So the bigger, rounder, more dense are gonna be in A, and the smallest, low density, flatter ones are going to be found out in zone D. That's on the test tomorrow. Keep that in mind, or not tomorrow, but Monday. Which of the following is not a factor that affects the rate of weathering of rock? Do process of elimination again. One of these does not control weathering. Not bad. So rock characteristics, that's like its hardness. That's like if it bubbles with acid, that's a characteristic. The amount of exposed surface, remember we talked about this a bunch. When a rock gets broken, it has more exposed surfaces, then it will weather faster, just like sucking on a sucker. If you have a whole sucker, it's gonna take a long time to dissolve. A sucker that's crushed up into pieces, it will dissolve faster in your mouth.
What are the characteristics, like what it's made of?
I just said it.
Oh my gosh.
It's like it's whether it bubbles with acid
Yeah,
or
that's what I
its hardness.
Like made with calcite.
Yep.
Yeah.
Sorry to get to see the movements there. Which climate is ideal for chemical weathering? Okay, well, we're getting closer. Hot and wet, not hot and dry.
You got it wrong.
Oh, boy.
Okay,
If a stream were straight, where is the water moving the fastest before you click the button? It's not the bottom. It's not the bottom, so it's not yellow or green. I shouldn't be. So when I say it's not the bottom, the river is moving faster near the surface. We have not talked about this. Why would a river be going actually slower along the bottom?
Because the rocks.
Because the rocks and the dirt, they're going to basically cause drag on the water, which just means it's going to slow them down.
And probably because it carries more sediment.
Oh, good point there too. Yep. So if it's carrying more stuff, it's got to move slower. So it is near the surface, and it says if the stream is straight. So we're not going to be near the banks if it's straight. It's going to be in the center if it's straight. What factor does not affect deposition? So the size of a particle, the density of the particle, the color of the particle, or the shape of the particle? Oh, good. The color does not change how fast it gets deposited. Which is the best example of physical weathering? Okay, the formation of a sandbar, that's deposition. This was asking about weathering, so the breaking down of rocks. So a rock cracking is physical weathering. A major, this one is going to be answer green. So floods are caused by fast snow melt or a lot of rain or frozen soil, which is not going to be on the test.
So you're trying to joke with us?
No. Sorry. I didn't mean to trick you. Which type of sediment would be deposited by a glacier? Oh, good. Unsorted. Be careful with this one. If granite and marble were exposed in an area with hot and humid climate, what's going to happen? Will the granite weather most rapidly? Will both rocks weather at the same rate? The marble will weather most rapidly, or neither rock would become weathered? You might want to use your reference tables to help you. Hint, the rock chart. 6 and 7. Look at what they're made out of. Maybe that will help. We changed to relaxing. Granite is an igneous rock.
Got it.
Hey, not bad. The marble will weather most rapidly. Why? Hey, marble is made out of calcite. Granite is made up of a whole bunch of very strong minerals like quartz and feldspars. All right. 5 more questions. Which agents of erosion and deposition sort by size? Read the answers carefully. Okay, wind and water, but not glaciers. Remember, the 3 W's are sorted, the 2 G's are unsorted. The process occurs when physical forces break rocks into smaller pieces. Break rocks into smaller pieces. Physical forces break rocks into smaller pieces. That would be physical weathering. Okay, good, because a whole bunch of people last class got it wrong. And they wanted to like fight me about it. An iron nail rusting is an example of. Yeah. You mean like the phrase oxidation?
Yeah, I was right.
Nice job.
I'm in 11th place.
What is the term to describe a bend in a river? That's a very bendy river.
Oxbow, is it like a name of it?
It's an oxbow would be this if during a flood, it skips, like it just cannot go around this huge bend and it would cut off here and end up making a little leak here. That would be an oxbow.
Oh my God, I got it right.
Okay, nice work, a meander. I just want to point out this is a great picture. See how there's so much sediment being deposited on the inside of this curve, but a little beach has formed there. Fun facts. Is this the last one or is there one more? A small stream that flows into a larger stream. Always great.
Oh. Picture helps you a lot.
It does?
Yeah.
I don't feel like it does. Okay, so
Well, it's a triangle, so I thought it was a delta.
yeah, so that's exactly what I wanted to tell you. Is if you guessed a delta, you may not know what a tributary is. That's a small stream that flows into a larger stream. So it's like any little stream that flows into the Cattaraugus Creek, which then empties into Lake Erie. But a delta, where does a delta form? By the way, this is on the test on Monday.
Where a river opens up to the marketplace.
And he's doing this in case anybody didn't look back at Adam. A delta is a triangle shape at the base of a river. It is where a river empties into a lake, not a stream that flows into a larger river. That's a tributary. And a gully, no.
What's a gully?
A gully would be like I guess a valley or a really large ditch. Last question. At a meander, erosion is taking place where? The outside of the curve, near the end, the inside of a curve, or the same on both sides? All right, always on the outside of the curve is erosion, the inside of the curve is deposition. Let's congratulate our winners. Nice job, Sina and Seth and Lydia. Good work, everybody. We have a few minutes. Would you guys like to try to play a different game? It's not review, it's just something different that's kind of new to me. What I need you to do, is on your computer or your